Okay, calculating average rate of change, which is 16C, and then estimating instantaneous rates of change, 16D. Alright, so we'll do 16C first, unsurprisingly. Cool, we've got this, distance over time graph. So I've got minutes on my x-axis, kilometres on my y-axis. Written down the specific points where all these changes happen. We're going to say that this is all very nice straight lines, which is definitely not realistic, but that's okay. We're doing a nice simple thing to begin with. So we're starting at 0, 0, going to 5, 5, up to 8, 9, 12, 9, 13, 8.5, 16, 4, 22, 0. Cool. Okay, well, what we want is an average rate of change. Now in this case, our rate of change is going to be a velocity, a speed. So, how do we know that? We've got y-axis kilometres, x-axis minutes or time. So if I've got a distance over time, that's speed. Brilliant. Okay, well, how quickly are we going for this first section? Well, we just said before that, oops, where's my red? Speed equals distance over time. We're going to improve on that slightly, but hopefully that's a familiar concept. Cool, alright, well, I went from nothing up to 5 kilometres. Okay, so I've got 5 kilometres over. How much time went by? 5 minutes. Okay, so I've got kilometres, minutes. Cool, 5 over 5, that's nice and boring. 1 kilometre per minute. Right. Now, we could change this into meters per hour, which, kilometres per hour rather. So kilometres per hour. Well, how am I going to get from there to there? Well, I need 60 minutes in an hour, so times that by 60 kilometres an hour. Brilliant, fine, boring. Cool. Similar story, okay, what about this next section? Well, it looks like it's pretty similar, but we should probably calculate that out to be sure. Okay, so blue section, which is now in here. I'm going from 5 up to 9. Okay, so obviously that's 4, but I'm going to write this as 9 minus 5 over. Okay, I went from 5 minutes to 8 minutes, so 8 minus 5 is how long that I've actually gone for. Brilliant. 4 over 3, so I've got 4/3 of a kilometre per minute, times by 60 again. It gives me what? 20 is 80. 80 kilometres per hour. Cool, so it turns out slightly different, but similar. Okay, great. Well, what about this middle section? Well, this is always your favourite part to calculate because it's got the best number in there, but we'll do it anyway just for completeness. Okay. I started at 9 and I ended at 9. Alright, 9 minus 9, great. My time, I went from 8 to 12. Okay, 12 minus 8. Brilliant, I've got 0 over 4, fantastic. That's the best number ever. Cool. Okay, well, that seems weird. We travelled at 0 kilometres per hour. Well, what does that mean? Well, that means I'm stationary. Brilliant. If I'm stationary, what happens? Well, time goes by, but I don't move. Well, perfect, because time was elapsing, but my distance had not changed at all. Perfect. So, nice horizontal lines like this, if we're talking about distance and time, they mean that you're just stationary, that you're doing a whole lot of nothing, which is fantastic because that makes life very easy. Okay. Next bit. Cool, we've got this tiny little section in here. Alright, I'm now going from 9 to 8.5. Okay? Now, I've got to be a little bit careful here because it's not 9 minus 8.5 because I started at 9. So, I've actually got to flip those around. So, 8.5 minus 9 over. We went 1 minute's worth, we went from, which was this, 12 and 13? Yep. So, 13 minus 12. Brilliant, that gives me negative 0.5 over 1, so that's just negative 0.5 times by 60 gives me negative 30 kilometres per hour. Ooh, that's bad. Instead of writing, cool, negative 30 kilometres per hour. Alright, well what does that mean? 30 kilometers per hour we're fine with. It's the negative that's going in there. Your speedometer doesn't typically go backwards. So what does that mean? Well, it means we're going backwards. Or in other words, reversing. Or does it? Well, that seems a little weird to be going backwards at 30 kilometers an hour. I mean, you could do that, but that seems like a really bad idea. Perhaps instead all that means is we've not really thought about this. We're going to change that and not talk about speed, we're going to talk about velocity. So, we should probably be a little bit careful with our wording from here on out. Velocity takes into account which direction you're moving. You could say that you're moving backwards as in backwards like that, or alternately you could say positive velocity, negative velocity. So even though to me I'm always moving forward through that, to the camera I'm moving left and right. And so if we define right as positive, then left is negative. And similar story, if up is positive, then down is negative. If that way is positive, then that way is negative. Cool. So that's all that negative means, it's just saying a direction. We're going back to where we came from. Okay, fine. So that was tiny red section, brilliant. Alright, what colour am I up to? Orange. Okay, so last bit, which is getting a bit tedious at this point, but we'll keep going. So we went from 9 to 4, okay, so get these the right way around. 4 minus 9 over 16 and 13, 13.50, yep. Is that what I just said? 13, yep. Minus 5 on 3, times that by 60, what do we get? Times 20 is minus, yeah, minus 100. Does that seem right? So, minus 5 over 3 times by 60, yes, gets rid of that, gives me 20, 5 by 20, yep, cool. 100 kilometers an hour is racing along now. Cool, still with the negative in there because we're still coming back home, okay. And last little section, we'll do that in black because I'm out of colours. 4 to 1, 4 to 0 rather, so that. 1622 gives me negative 4 over 6, gives me negative 2/3 times 60, well, negative 40 kilometers per hour. Okay, beautiful. Well, does all this make a whole lot of sense? Well, let's think about this. 60 kilometers an hour, I'm travelling somewhere, alright? I then changed to 80 kilometers an hour. So what happened? I got a little bit faster, but I'm still going in the same direction. It's still positive. Okay, fine, that's great. So what does that mean? Well, it means as I go up, I'm going away from wherever I started. Okay, fine. I then hit the 0. Well, I must have stopped somewhere. Rather abruptly, apparently, but that's okay. I've stopped somewhere for 4 minutes. Fine. Then we've got this little red section. Okay, what's happening? I now have a negative velocity. What does that mean? It means I'm going back the way I came. So I'm going back home. Okay, fine. Similar story, negative 100 kilometers an hour. Okay, well, that means I'm going home quite a bit quickly. More quickly. Great. So even though it's a lower number, you're actually going faster in terms of speed, even though the velocity is more negative. Brilliant. Then we're going for this last bit from 16 to 22. We've slowed down to 40 kilometers an hour, but we're still going in the home direction, so it's still a negative value. Brilliant. So let's see if we can come up with a story. Great. Travelling off to the shops at 60 kilometers an hour. We make it onto one of the main roads. We're at 80 kilometers an hour. We stop at the shops for however many minutes it was. 4 minutes. Great. Start home. Apparently we get caught in some kind of traffic. We decide, no, I'm out of here. I'm doing something else. Get onto a freeway or something. Doing 100 on the way home. Beautiful. Have to get off the freeway at some point, unless you live on the freeway, which is probably not the best place to live. And we're coming home at 40 k's an hour. That seems perfectly legitimate. Great. Okay, well, let's move over to something a little bit more realistic, hopefully. Cool, I'm starting, and for now we'll assume that this is time in, I don't know, seconds and then meters up this way. Sure, why not? Okay, I've got some object, it's moving up and over. Well, let's go back to this and see what that might mean. Okay, as I go faster and faster, this thing gets more and more steep. Okay, so I went from 60 and then slightly steeper up to 80. If I'm horizontal, I know that means I'm stationary, and if I'm going down, the steeper it goes down, the faster I'm going, I'm just going in the other direction. So steepness translates to speed. Whether it's going up or down just tells you whether you're going away or going back to home. Fine, okay. So I start off like this, and then I go up to there. Okay. Well, let's see if we can get an average rate of change first. So, first bit. I want to get an average rate for that first 5 seconds. Alright, well what did we do over here? Well, some of the more astute of you may have noticed, all we're doing is calculating the gradient of this thing. Brilliant. Well, how do we calculate gradient? You're just doing rise over run. Alright, so we've got a rise here of 3, a run of 5, so I've got 3/5 of meters per second if those were our units, which I'll put in since I've said it now. Meters, seconds. Cool, so 3/5 of a meter per second. Not particularly setting the world on fire there, but that's okay, they're just numbers. Beautiful, okay. What about this next section? Over here, okay, well, I've gone 8 down to 3. So, I've gone, yes? Is that what I've done? 8, 3? Yep. So, my rise is going to be 8 minus 3. My run is 8 minus 5. Cool, so we've got 5/3 and units, meters per second. Beautiful. Does that make a bit of sense? Well, yeah, this is looking more positive. Okay, fine. Next section, 8 through to 13, so we've got a height change of 2, so 10 minus 8, and a time change, 13 minus 8, gives me 2/5 meters per second. Okay, does that seem to make sense? Well, are we going slower than this bit? Well, yeah, we look like we're slowing down, that makes a bit of sense because we're curving off. Right, does this look slower than this? Not necessarily 100% clear, but it looks a little bit flatter. Okay, so it's a little bit lower. Yeah, alright, I can live with that. Next little bit. Great. Well, it's already a flat line, so we should probably be able to say, well, it's a dead flat, that means we must be going nowhere. But we'll calculate it just to be sure. We've got 10, which doesn't change to 10, over 16 minus 13. Brilliant, that's a nice boring 0. Fantastic. Cool, so I'm going nowhere for that last bit. Okay, so we calculated the average rate of change. But is this thing really moving that quickly, or no? Well, if we're calculating an average rate of change, that's the same as saying the gradient of the straight line connecting 2 points. So we were actually talking about that. Oh, well that's a problem because that purple dotted line does not match this black solid line. So we aren't describing the same thing anymore. For the blue one, that's fine, because this blue dotted line, if I could draw perfectly, is exactly on top of it, by the looks of it. So that's actually perfectly valid, because it's a perfectly straight line, so the average rate of change and the actual rate of change, the instantaneous rate of change, perfectly the same in this context, that's fine. Well, what about this guy? Well, we've got the same problem as the purple, because the straight line is that's supposed to be a straight line. So they're definitely different. The stationary thing, beautiful, well, that's lovely, because they're the same. They're both just a nice flat line. Alright, well, what's actually happening in this purple and green section? We'll deal with the purple first, since it's there first. Well, at the start, this thing looks like it's not moving at all. Or if it is, it's moving exceptionally slowly. Well, we could take tinier pieces, so we could go, what about if I estimated this thing, which looks like it's about 0.1, so I'm going at 0.1, what's that? Oh, did I write meters and seconds backwards? Yes. What a fool. Let's try that again. You almost always have time going this way and distance going that way. This could be a velocity or anything else, but almost always time will go that way. just depending on what you're doing. Anyway, sorry, so that should be about 0.1 meters per second, because for this 1 second I'm going up about 0.1. Okay, so I start off slow and then I get progressively quicker. It looks like this is at about 2, so this will, between time 4 and 5, that's 1 second, I'm going from 2 to 3 in meters, so that's going at about 1 meter per second. Okay, that seems about right, and then 5/3 is for this bit, so it's getting progressively faster. What if I wanted to know specifically how fast this thing was going at, say, 3 seconds? Well, that would be right about there. How could I do that? Well, we're talking about the gradients of nice straight sections. That works perfectly well. So I need, how straight is this bit? Oh, it's on a curve, that's really annoying. So what we're going to do is draw what's called a tangent line, which, if you know what the word tangent means, it's tangent. So one way of describing a tangent line, if you think of a tennis ball and a ruler, if you put the ruler on top of the tennis ball, the ruler will be tangent to the tennis ball at the point that it touches. So my solid purple line here is tangent to the black curve at the point 3, 1. Cool. Alright, great. Well, why did we do that? Let's say it looks like this goes through the point 4, 2 and the point 2, 0. Alright. Well, perhaps now we've got a straight line. We could say, alright, my rise is going to be 2, so I've got 2 minus 0. My run, I'm going from 2 to 4, so 4 minus 2. Go, 2 over 2 gives me 1 meter per second. Actually, let's write that on the next line down. So, at time 3 seconds, I can estimate my instantaneous rate of change. So I estimate my instantaneous rate of change is 1 meter per second at the time 3 seconds. So if I was driving along in this vehicle or whatever else have you, and I'm looking at the speedometer, at exactly 3 seconds I take a picture of the speedometer, and it's probably going to be somewhere around 1 meter per second, if those are the units that my speedometer's in. Beautiful. Okay, well we could do this at other points as well. Let's pick somewhere around there. Okay, if I draw a tangent line to that, and now we're going to get a bit messy, but that's okay. How's that looking? Is that at 4? Oh no, I missed. Something more like that. Okay. Cool, well, now I've got some new points. Great. And where's this look like? Trying to make it a bit even. About there. About there-ish. Something like that. Okay, well, it looks like I've got a couple of new points. Let's say this is what? 2.5, 0. 2.50. And this looks like it's about 5.5, 3.5. Cool, okay, well, we can calculate that through. Oops, that's a new calculation now. Cool. y2 minus x, y2 minus y1, and then x2 minus x1. Cool, so we've got 3.5 over 3, brilliant. It is whatever it is. Beautiful. Cool, well, it's a little bit bigger than 1, so it's a little bit faster than this. That makes sense because we're expecting this thing to get progressively faster. Beautiful. Alright, we'll try another one up here on the green somewhere. Arbitrarily, I'll pick 9 because I can. Somewhere about there. Maybe about there. Looks a bit better. Cool. Draw a tangent line. Brilliant. Alright, what does this look like it lines up with? Where's 8? 8's about there. What was this? This was at, that was supposed to be at 9. I don't think I've drawn a great tangent line there. Let's try that again. It's about there, that's 9. Okay. Something like that. Cool. That's looking a bit better. 8 looks like it's about here somewhere. 10 looks like it's about there somewhere. Maybe, maybe not. About there. 8 looks like it's here. Looks like my scaling isn't brilliant. Somewhere like that. Yeah, somewhere like that. Yeah, that's not terrible. Okay. Cool. Alright. Well, this looks like it runs through, what, maybe 7-ish almost. I'll move that there. Yeah, 7 seems pretty good. And over across here, what have we got? 9, 10, 11. And what's that in line with? That looks like it's in line with 11. Beautiful. Without even doing a bit of math, you can cheat that one if you want, but we'll do it anyway. So, cool, 4 on 4 gives us a nice 1 meter per second. Cool, does that make sense in our context? Okay, well, we're going, in the blue bit, we were going at 5/3 meters per second, okay? Well, it looks like we should be slowing down. Is 1 less than 5/3? Yeah, that's fine. And then we should eventually slow down to 0. Well, 1's definitely bigger than 0, so that's all good. Cool. Well, this all seems a bit fiddly, and it is. Despise doing this. Conveniently, when you're doing stuff in the book, you'll have grids on this. You want a pencil, and you want a ruler, and you want to rule tangent lines quite nicely. Unfortunately, drawing grid paper on a whiteboard takes forever, so I haven't bothered to do that, and we're just doing things by eye. You can estimate by eye. That's fine. Unsurprisingly, it's less accurate. This is a bit of the to and fro that you're going to have to do whilst you're doing estimates of instantaneous rates of change. We'll do how to calculate them specifically as we go further into calculus, but for now, this is what we're doing. We can very reliably do average rate of change, and we can estimate instantaneous rates of change. That's as good as it's going to get for now. Cool. If you've got any questions or anything, email as always. But for now, that's 16C, 16D. Enjoy.